video we will learn that how we can get betas as well as standard error of betas with the help of matrices. And we should follow the matrices rules as well. Here we use m mod function and m inverse function of Excel, and we will also use transpose function of Excel. That all these functions are used for matrices. But before discussing all these functions, first, we understand that what is regression. Regression. Now here is regression that y had to go to beta 1 plus beta 2 x2 plus error term. But here you can see that x1 is missing. X1 is basically matrix of 1. It is column vector. And if we put 1 and we put here x1, we will get, and if we multiply it by 1s of matrix, we will get beta 1. So the use of by using matrices, we should put ones in x1 according to data size. Now, first of all, to multiply matrices, we should know the matrix multiplication concept. For matrix multiplication, there is rule that number of columns of first matrix should be equal to number of rows of second matrix. Now, to get betas, the betas main formula is here, that we transpose X matrix and multiplied by X, and we take matrix inverse, and that is multiplied by transpose of X matrix multiplied by Y. So we have basically 3 multiplication to get betas. In the same way, we can get variance of betas by using this formula S square, and S square is basically summation U hat square divided by n minus k. And even we can get this U hat with the help of matrices, right, like this one. If we multiply the transpose of u by transpose of u by u, we will get this summation U hat as square. Now let's start here. First we will get x matrix. Now the x is 4 by 2. This is 1, 1, 1, and 2, 3, 4, 5. The dimension is 4 by 2 because we have 4 rows and 2 columns. And if we take its transpose, rows becomes columns and columns becomes row. So transpose of x is 2 by 4. Now, if we want to multiply this x transpose by x, so the dimension of x transpose is 4 by 2, 2 by 4, and x dimension is 4 by 2. So as number of columns of first matrix is equal to number of rows of second matrix, and the resultant matrix will be this one, 2 into 2. So we will get, so first of all, we locate the position as well. But if we are using Excel 365, so we don't need to locate the highlighted area. And we will get inverse of matrix. And now for this is for x transpose x, and inverse of this x transpose x, and then we need x transpose of y. So x transpose, we know that its dimension is 2 into 4 and y dimension is 4 into 1. So when we multiply x transpose into y, the dimension should be 2 into 1 of resultant matrix. Now, when we multiply this, the first one, this one, and the second one, we will first write the dimension 2 into 2, and the second matrix dimension 2 into 1, and the resultant matrix will be 2 into 1. So it will give you, by applying this formula, we will get betas in this way. And now after getting the beta, then we will calculate variances of beta with the help of this formula, and I have already explained. Now, first we will get x transpose. So its dimension should be 2 by 4. So 2 rows, 1, 2, 3, 4 columns, and we will use transpose function. And then press Shift Control Enter. So this is transpose of X. Now we multiply X transpose with X, and the resultant matrix should be 2 into 2. So we locate again the space and M merge multiplied by this X. And again, Shift Control Enter. Now we have X transpose X, and we will take its inverse, M inverse. And again, press Shift Control Enter. Now we will get X transpose Y. We have X transpose, this one, and then X transpose is multiplied by Y. So resultant matrix should be 2 into 1. So 2 rows and 1 column equal to M merge. First X transpose, this one, multiplied by Y matrix, and then press Shift Control Enter. Now after getting these two, now we will multiply again so that we can get beta, and dimension should be 2 into 1. So we will locate the space and M multiplied by X transpose Y. So look at, we have the same beta that we have already done when we were doing calculation manually in my previous video lecture. Now to get S square, for S square, we need, here is the formula, summation U hat square n minus k, and number of observations are 4 and number of estimators 2, so it is 2. So summation U hat, for this we will use to get Y hat, we would use this formula XB. So we multiply, this is basically formula, X multiplied by B with the help, beta with the help of matrices. So X dimension is 4 into 2 and B dimension is that we have calculated right now 2 into 1. When we multiply X into B, the dimension should be 4 into 1, and we have this dimension, and we will get Y hat in this way. First, we calculate Y hat, and Y hat can be calculated by multiplying X matrix with beta matrix. So again, M merge, here is X matrix, and that we will multiply with second matrix, that is of betas. And now we calculate the difference, Y minus Y hat. And now to get summation U hat square, for summation U hat square, we can multiply this U hat by U hat, and it will give us single value. So that should be M mult. And now we will take its transpose of U hat multiplied by this U hat. We will get summation U hat square, that is the residual sum of square. And if we divide it by n minus k, that is by 4 minus 2, 2, we will get S square. So it is the value of S square. And then look at the formula, that S square is multiplied by X transpose X and inverse of it. And we have calculated this one, mean we multiply with this matrix, we can get variance of matrix. And I'm here writing variance of betas. Variances of betas. And first we locate space, and we have already this matrix, just we don't need to locate space. We multiply simple this S square, and just we will fix it multiplied by this matrix and just copy it to the next cell and copy it down. So the diagonal of these matrix, I'm highlighting this one. These are basically our variances of betas. So to get standard error of betas, we will take its under root power 0.5 and control C and control V and control X. So here we have standard error of betas, and it is the same as we have calculated earlier. Thank you very much for watching this video, and even we can use only one single formula to get this variances of betas as well as to get betas. I will explain it in my next video. Thank you very much.